Alright, this problem is very similar to number one. We're going to use the same formula, the only difference being that we're going to have to solve for C instead of a delta T. So what do we have here? We've got 228 joules of heat are absorbed by 125 grams of copper at 22.38 degrees Celsius. Temperature increases to 27.12 degrees Celsius. What's the specific heat of copper? So we have our Q, that's going to be 228 joules. We have our mass, 125 grams. And our delta T is going to be our final temperature minus our initial. So it's going to be 27.12 degrees Celsius minus 22.38 degrees Celsius. And we're going to look for our specific heat of copper. We're looking for C. So our formula Q equals MC delta T. We can rearrange this formula to solve for our C. So to get C all by its lonesome, we're just going to divide by M delta T. Do that to both sides. And we end up with C is equal to Q over our mass times our change in temperature. So now we're ready to plug some things in. Our Q is going to be 228 joules. Our mass is 125 grams. And our change in temperature, if we do the math to find our delta T here, we find it's going to be 4.74 degrees Celsius. Plug this all into a calculator, and it should spin out somewhere on the order of 0.385 joules per gram degree Celsius. And that is our specific heat of, in this case, copper metal.